Let me say this clearly, most buildings don't fail because of earthquakes, they don't fail because of wind, they don't even fail because of bad materials, they fail because the process was weak. Somewhere early on, important questions were skipped, loads were guessed, soil was ignored, drawings were rushed, and decisions were made based on confidence instead of physics. Structural engineering exists to stop that from happening. It's the quiet discipline that turns beautiful drawings into buildings that can actually stand up in storms, in earthquakes, and over decades of real use. In this video, I'm going to walk you through the entire structural engineering design process, step by step, from the moment someone decides to build to the moment people safely live and work inside the structure. No jargon, no shortcuts, just how it really works. What structural engineers actually do. Structural engineers are responsible for making sure buildings and structures stand up safely. They work on houses, high-rises, bridges, schools, and commercial buildings, while architects focus on how buildings looks and feels. Structural engineers focus on how it carries loads and resists forces. Buildings do not fail randomly. Most failures happen because the design process was weak or incomplete. Structural engineering exists to prevent those failures by understanding forces early and designing for them properly. What happens before a structural engineer gets involved? Before a structural engineer starts work, 3 key things have already happened. First, the client has decided to build something. This could be a government project, a developer's investment, or a private home. Second, an architect has prepared drawings that show the layout form and appearance of the building. These drawings describe the vision but do not explain how the structure will resist gravity or lateral forces. Third, a geotechnical engineer has tested the soil and produced a soil report. This report explains the strength and behavior of the ground and plays a major role in foundation design. Ignoring this information often leads to serious structural and financial problems. Turning an idea into buildable structure. At this point, the client has an idea, architectural drawings, and a soil report. To move forward safely, a structural engineer must convert these inputs into a structure that can be built and safely used. This is where structural engineering bridges the gap between concept and reality. The engineer's role is to make sure the building can stand up under real-world conditions. The analysis stage explained. The analysis stage is where the structural engineer identifies all the forces that will act on the building. These forces are divided into vertical loads and horizontal loads. Vertical loads include the weight of the structure, walls, floors, furniture, equipment, and occupants. Different parts of a building carry different loads, and these differences must be carefully considered. All loads follow a load path. Loads move from the floors to beam, from the beams to column or walls, then into the foundation, and finally into the soil. A weak link anywhere in this chain can compromise the entire structure. Understanding horizontal loads and stability. Horizontal loads come mainly from wind and earthquakes. These forces act sideways and try to push the building over. Structural engineers calculate these loads using national codes based on real data and research. Because columns alone are poor at resisting horizontal forces, buildings need dedicated stability systems. This may include reinforced concrete shear walls, bracing systems in steel structures, or plywood and strap bracings in houses. Stability is not optional. Without proper lateral resistance, even a strong building can fail. The design stage. Sizing structural elements. Once all loads are known, the design stage begins. The structural engineer determines the size and strength of every structural element in the building. This includes slab thicknesses, column and wall sizes, foundation dimensions, and steel reinforcement quantities. These decisions are based on engineering mechanics, material properties, code requirements, and experience. Engineers often use software to assist with calculations, but understanding the results is essential. Software supports the process, but engineering judgment controls it. movement, deflection, and serviceability. Structural design is not only about preventing collapse, building must also behave well in everyday use. Engineers check deflection and movement to ensure the floors do not sag excessively and buildings do not sway uncomfortably. Excessive movement leads to cracking, damaged finishes, and long-term maintenance issues. A building that stands but performs poorly is still a failed design. The drawing stage. Communicating the design. After the design is complete, it must be clearly communicated through structural drawings. Calculations alone cannot be built. Structural drawings show layouts, reinforcement details, sizes, spacing, and connections. Drafting teams usually prepare these drawings based on the engineer's instructions and sketches. Clear drawings reduce mistakes on site. Unclear drawings create delays, confusion, and extra costs. The construction phase and site inspections during construction. Builders and contractors construct the structure using the drawings. Structural engineers remain involved through regular site inspections. These inspections ensure the structure is built according to the design. When questions arise or mistakes occur, the engineer provides guidance and safe solutions. Engineering judgment during construction often prevents small issues from becoming serious problems. Why structural engineering matters. Structural engineering is about responsibility. People live, work, and invest their money in building designed by engineers. A weak design process leads to stress, delays, and costly failures. A strong process creates safe, durable structures and peace of mind. This is why structural engineering plays a critical role in turning ideas into reality while protecting lives and investments. So that's the structural engineering design process. It's not magic, it's not guesswork, and it's definitely not calculations on a screen. It's the sequence of decisions made in the right order. Understanding forces, respecting the soil, designing clear load paths, communicating clearly through drawings, and staying involved during construction. When this process is followed properly, building feels calm, they don't crack unnecessarily, they don't move in ways that scare people, and they don't turn into expensive lessons. When the process is ignored, the structure might still stand, but the stress shows up in delays, disputes, and regret. Structural engineering is about responsibility. People trust these buildings with their lives, their families, and their money. Get the process right and the building will look after them in return. I'm engineer Abdirahim Mohamed, your construction therapist. If you want to build smart, sleep well, and avoid becoming a construction story told at weddings, subscribe for more practical construction guidance. I'll see you in the next one.